So, are your best engineers burning out? The reason might not be what you think. See, there's this quiet epidemic in tech called alert fatigue. Today, we're going to break down why that endless flood of notifications is just crushing your teams, and how a new wave of AI is finally bringing some sanity back to the on-call chaos.
Okay, let's just start with a number that sounds, well, it sounds made up, right? 98%. What if I told you that you could slash your alert noise by that much? That's the actual promise of modern AI tools, and it gets right to the heart of the problem that is just hammering engineering teams everywhere.
You know, this quote just absolutely nails it. It's not that engineers stop caring, not at all. It's that they literally become desensitized. Their brain just can't process it anymore. Their most valuable resource, their attention, is just completely drained by a system that's screaming wolf all the time. That right there is the definition of alert fatigue. I love this analogy from Victoria Metrics. It's perfect. A doorbell is useful, right? It tells you something important is happening. But what if it just rang constantly, day and night, for things that absolutely do not matter? You'd start ignoring it. You might even rip it out of the wall. And that is exactly what is happening with our monitoring systems today. So what does this crazy, nonstop doorbell actually look like for the person on call? We're talking about teens getting thousands of alerts every single day. And the result? Honestly, it's terrifying. Studies are showing that up to 30% of the actually important alerts are being completely missed. So this isn't just about stress. This leads to real outages and huge business impact, all because the critical signal got buried in an avalanche of noise. All right, so let's zoom in a bit and put a formal name to this thing. What is this phenomenon that's turning our safety nets into a major source of stress? At its core, you gotta understand that alert fatigue is a psychological response. It's what happens when the human brain gets hit with way too much information, too many interruptions, and just way too many false alarms. Responders don't get lazy or careless, their brains are just full. They're completely overwhelmed, and that makes it almost impossible to pick out the important stuff from all that background noise. Now, this is a really important distinction to make. Alert fatigue is being exhausted from all the noise. Incident fatigue, on the other hand, is being exhausted from all the actual work. So you have to ask yourself, is your team tired from sifting through junk, or are they tired from actually fighting fires? Knowing the difference is the absolute first step to finding the right solution. And believe me, the costs here are staggering. Operationally, you get these massive failures. We saw it with GitHub, we saw it with Delta, where critical alerts just got lost in a sea of noise. For your people, it means burnout, terrible sleep, and your best talent walking out the door. And for the business, it's time down the drain, longer and more expensive outages, and a complete loss of trust in the very systems meant to keep you safe. So where do we even start to fix this mess? Well, the first step isn't to go buy some shiny new tool. It's about applying some basic first aid to the systems you already have. These are the practical, hands-on fixes that can make a difference right now. There are basically 4 key moves you can make. First, tune your thresholds so you're not getting paged for every little temporary spike. Second, group related alerts together so you don't get 50 notifications for what is really just one problem. Third, deduplicate those annoying flapping alerts. And last but not least, for goodness sakes, silence things during planned maintenance. Let's see what that actually looks like. Okay, check this out. That little 4 parameter right there, it is so powerful. This one little line of code tells your alerting system, hey, don't even bother me unless this problem has been happening for 5 solid minutes. This is your best friend for filtering out stuff like a quick CPU spike that might cross a line for a second but isn't a real sustained issue. And this is a beautiful example of the power of grouping. Instead of getting a separate page for every single pod that's failing in your Kubernetes cluster, this config tells Alert Manager, hey, just bundle all of that up into one single notification for that cluster. You go from an insane storm of 50 alerts down to one clear signal. Hey, something's wrong in this cluster. Now look, manual tuning is a fantastic first step. You should absolutely do it, but it's not enough. It's a constant battle, and it just can't keep up with how complex our systems are now. This is where AI comes in, acting like an intelligent co-pilot for your on-call team. Let's see how it works. So what's the big leap here? Well, traditional tools just matched keywords. If the words in 2 alerts aren't exactly the same, boom, you get 2 separate alerts. It's super rigid. AI is way smarter. It understands meaning.
It knows that an alert for high error rate and another for failing health checks on the exact same service, yeah, that's the same problem, even if the words are different. So how does it pull this off? Well, AI platforms use a few really clever tricks. They use dimension matching to group things by scope, like an entire service, not just one little pod. They have what's called service topology awareness, so they actually understand that a database failure is going to cause API errors downstream. They use natural language processing, that NLP we just talked about, to understand the meaning of the alerts. And maybe most importantly, they learn from your past incidents to spot patterns when they happen again.
And this is where tools like Rootly and PagerDuty AIOps come into the picture. They're not trying to replace your existing monitoring tools like Datadog or Prometheus. No, instead they sit right on top and they drink in all that raw data, acting like this super intelligent filter that turns thousands of noisy signals into just a handful of actually useful incidents.
So what does this big transformation actually feel like? Let's do a quick before and after to see the real-world impact when you go from a noisy system to an intelligent one. Okay, here's the before. A single problem, let's say a database falls over, and it sets off a huge chain reaction. Your monitoring tools do their job. They fire off 147 separate alerts. The on-call engineer's phone just explodes. It's absolute chaos, and it's impossible to see what the real root cause is.
And now, the after. The exact same problem happens. But this time, instead of 147 alerts blowing up your phone, the AI correlates everything and presents you with just 3 clean, consolidated incidents. Maybe one for the database, one for the API, and one for the front end. That's a noise reduction of over 98%. It is a total game changer. And the business impact of this kind of clarity is just huge. When you take all that cognitive load off your engineers, they can find and fix problems way faster. This chart shows what happens to your mean time to resolution, your MTTR. With manual triage, engineers are just drowning, trying to figure out what's even happening. With AI, they can jump straight to fixing the actual problem. And honestly, this right here is the most important part of this whole thing. It's not just about fixing problems faster. It's about changing the very nature of what it means to be an engineer. When you automate all that soul-crushing work of triage, you free up your brilliant team to focus on what you hired them to do in the first place: build better, more resilient products. So that leaves us with one last question for you to think about. I want you to take a hard look at your own on-call experience. Is your alerting system really a safety net, giving you clear, actionable signals when things go wrong? Or has it just become part of the problem, another source of noise that you've slowly learned to ignore?